Well, happy Monday. So in terms of things that deal with the human factor, right, and why this is a good thing to get into, is to learn to avoid these and don't do these. And next semester we'll talk also all about ethics, and I'll make a very strong case that these things are very immoral, and we've got a strong standing to say, no, employer, I'm not doing this. But there are all sorts of deceptive things we can do to make users essentially give us more money, more time, more energy, more effort, more money most of the time. So there are certain laws around certain things. There's legal cases. All sorts of people use deceptive patterns. HP's ink subscription service, when you stop paying, even if the ink cartridge still has ink in it, they won't let you print anymore because you stopped paying for their service. This is very wasteful. I can sort of understand from their business perspective that someone's going to order a fresh new set of cartridges and then cancel, and now all of a sudden they can print another free 100 pages. Okay, sure, like if you want to. Alternates the meaning of off and on in their email preferences. Skype usually wants people to get your address. Everybody wants your address book here. So there's all sorts of patterns here. So these are the types here. Preventing people from comparing. Confirm shaming, emotionally manipulate something, people, disguised ads, fake scarcity. All those websites are like, oh, there's only 3 left and 7 people have them in their cart. You have to buy now. It's on sale for the next 10 minutes only, when it's always that price all the time. That bunch of nonsense. Fake social proof. Oh, fake reviews, fake testimonials, fake messages. Trying to force them into some action, making things hard to cancel. Always all these hidden costs. Oh, it's only this much, but then there's extra ship. Oh, it's free, but $20 shipping and handling. Nothing costs $20 to ship anymore, but the handling is, their fee. Making things into subscriptions without people realizing it. This is why my son pays $15 a month for Fortnite, because he wanted to join the Fortnite club. He actually really likes it, but he didn't know it was a subscription the next month, and I was like, okay, Jeb, you owe me 15 more bucks. He's like, what are you talking about? I was like, for your Fortnite club. He's like, oh, that's an every month thing? I'm like, kid, he was 16 at the time. Like, read the thing before you sign it. Nagging, we're really good at nagging people over and over and over here. Making it hard to complete their tasks. Pre-selection, there's a lawsuit going on now with political fundraising. What's it here? GOP fundraiser. Select. What is it here? Recurring. I think I can find it here. Yeah. So they did an investigation on these deceptive political fundraising. It costs generally the elderly, because we like to pick on the elderly because they're bad at reading things. Some of them have lost their entire retirement savings. And you do all these deceptive things here, which is pretty awful. And the first person was in his 80s, donated $400,000. Confused because he didn't know he did that. And this poor guy had dementia. And he's giving away all this money, which is gone now. Drained his retirement savings. There's another one in here. You get text messages like, oh, there's a 900% match. If you donate now, someone's going to give 900% of what you give. There's that like fake urgency thing. This match only ends in the next 12 hours. You have to give now. Thankfully, most of us can reply stop, or your spam filter catches them nowadays because they're really irritating. Sometimes, because I'm a terrible person and it entertains me, I engage with some of them because it costs them money to send these text messages. So I'll send a couple back and forth just to make them waste their money, and then I ignore them. I really should probably spend more time grading things, but this also entertains me to make them waste their money. Anyway, yeah, so all sorts of nasty stuff happening here. So we're going to talk about ethics next semester. Right? It's also one of the required pieces of our accreditation, which is why we're going to use Unix next semester as well. But ethics I'm a huge fan of because we need to make sure that we're doing good things with software, right? And not only are we doing good things with software, but we design software in a way that you can't do bad things with it. Because it's really cool and easy to come up with a really cool feature and be like, oh, this would be amazing, and not really think about how it could be abused, right? Oh, wouldn't it be great? We could open our garage doors with our voice activation stuff. But now, someone from outside your house can shout in, Alexa, open the garage door, and your garage door opens. Like, if we don't have any sort of protections around these features, malicious actors can go through and do malicious things. So when we're designing our features and we want to think ethically, part of that is making sure that they can only be used for those good things. That sort of stuff. I've got a cool new feature on my pump here where I can talk to it from my phone, so I don't even have to pull it out of my pocket. So if I want to pretend like I'm not type 1 diabetes, I can completely hide it in my body, no one will ever see it, and I could just be playing with my phone, controlling it to give me more insulin. So nobody has to see it here. Now, I'm sure that's a really good feature, but they've done a lot of work to make sure not just anybody can connect to my pump and give me insulin, because that will literally kill me, right? Like that's a pretty big safety thing. So the pairing process to connect a phone to the pump is way more tedious than it should be, but for reasons, right? You got to make sure it actually does what it's supposed to do, and it's only verified on certain models. So the cheap phone I buy, because my little guy beats this thing up all the time when he watches YouTube, doesn't even work. So I'd have to buy a more expensive phone because they have to get certified phone model by phone model for this process and all sorts of fun stuff here. Sorry, that was a rabbit trail. Wow, how did we get there? Don't remember. It's good though. It's all good. So we're finishing up our project, the midterm review, and then for lab we'll do a little dictionaries exercise. We started building out a gradebook. What I'm going to ask you to do is make it more flexible. So take this given style of gradebook and make it so we can have the user add users, and add assignments, and score people. So we'll talk about that when we get there. And that'll be relatively quick because we've already got half of it done for the gradebook. Kind of the form and structure. We're just adding in those loops to go and control those things. And then remember, on 10:30 at 12:30 p.m. the exam will open in Canvas. It'll just be a Canvas quiz. I haven't published it yet. I'll go ahead and publish it. Probably finish that up today in lab. So it's ready for you. And it's the 15 quiz style questions. Short answer, true, false. If it's false, give me the correct statement. And then 3 coding questions that ideally take you 10 minutes, maybe 20 minutes. If it's going really long, it's maybe a paragraph worth of code. You just do it in PyCharm, copy paste it into Canvas. Please don't type code into Canvas. Please, 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 please. Okay. And please don't do it on your phone. I had someone take the midterm on their phone for some reason. They're like, oh, my computer wasn't working. I was like, go to a lab, please. Just don't do it on your phone. Typing Python code on your phone is the worst. Like, terrible, terrible experience. Anyway, but as long as you turn it in by 11:04, we're good. So the deadline will be 12:30 p.m., 11:04. Start it, open it, come back to it, close it, come back to it, open it, whenever you want. It's not timed. That's just not really worth it here. And it's not like you're going to get a huge advantage if you've got all week to do it, because it's pretty short. But take whatever time you want here. It is open book, open notes, open internet, but you can't give me an entire quotation as an answer. Right? English paper rules apply even to your paragraph. Right? So if you want to find, here's one little line or two that you found, great. But you need at least 50% of it to be your own original work here that you've done. You can cite your sources, but you may not work with other people. Right? That's the only limitation. And other people also means Chegg and their online services and things like that. Right? You can't post it to Chegg and when someone answers, be like, oh, look, I found it online. I actually had someone do that during a 3-hour timed exam back when I used to give timed exams. Like they posted it at the start of the exam, and 2 hours later they had an answer from Chegg. And they're like, oh, look, the answer was online. Like, that's not how this works. And they're like, you didn't say I couldn't. You said if I found it online, I could use it. Like, it's not hard to do the work, I promise, okay? Right? If this is hard, we need to have conversations. This is meant to be an easy midterm just to check in and see how things are going for you. If it's hard, you and I have to have a conversation about how to make sure you pass the class, right? If it's easy, great, things are going pretty well for you, we're on track. That's sort of the general check-in here. And then after the midterm, we get into some advanced topics. Again, we're not going to go super deep on a lot of these because we're going to hit these again next semester. So we're going to have an intro to the topic, scratch the surface of these for classes, look at exceptions in modules, look at files, take a week off for Thanksgiving, and then look at our last special topics, inheritance, recursion, and Python for data science. Just sort of wet your whistle for some of the cool things we can do. I spent a little bit of time last week showing you the JP Morgan's site that did some cool stuff. There's all sorts of amazing things you can do with Python for data science that's out there. But we need to understand what Python does first so we can read it and write it and modify it. When we come back, we'll pick up our last individual project here, project 3, and then 11:18 we'll assign the final project, and we've got up until 12:18 for that. So you have a month exactly for your final projects. And this is final project presentations, so you and your partner. Ideally, you partner up. It's not required. I always think partner work works out better for you if you can self-assign, because you've got someone to bounce ideas off of. And if you're actually working together, then yes, you're sharing code, right? It's not just this English conversation of, oh, here's the thing I was thinking about doing, which you're welcome to talk about, right? English conversations for code, I love it. It's really lonely to code by yourself and never talk to people. And turns out you're all really smart people, I believe it. But bouncing ideas off of other people makes your stuff even better, right? These collaborative processes get better. Now, at some point it gets too large, and if you get into committee work, you get garbage. You don't want a committee of 15 people designing stuff like that. It's just too much of a nonsense here. But 2, 3, 4, a nice small group of people who know what they're doing, it's fantastic. Someone had the 2 pizza rule. Was that Jeff Bezos? 2 pizza rule for meetings. Who is it here? Must have been Bezos, yeah. So how many attendees should we go to a meeting to something here? If 2 pizzas is not enough to feed everyone, you've got too many people there. I think that's a pretty decent rule here. You don't need 50 people giving you input on something here. That's all. All right, so we got to get into the midterm review. So let me go pull that up here, because you guys wanted to do that one first.
What do you mean, like, group project? Is it still like you're doing it individually?
For the final, you can work in a pair, and both of you will turn in the same project.
Oh, so then when you present, you're each presenting the same thing?
You could share the presentation. You could do the first half, they could do the second half.
Oh.
Or as long as you have a speaking part, I'm great with that. What I would not like is one partner to talk the entire time and the other partner to just sit down and not talk. At some point in your career, you'll be talking about the things you work on in front of your team or your group or whatever you're presenting it to here, so that's a skill we want to start developing, right? Yeah?
So now for the final project, we will be coding on Python. Let's say we make one app together, and you have an idea to edit the code. And as you know, like Python, how do you make it like accessible to the two parties so we can like edit whenever we want?
So the Git repositories can be set up so more than one person has access. So if you tell me I'm working with so-and-so, and here's their GitHub username, here's my GitHub username, I'll give you both access to it. So you both can commit and push and pull. It takes a little bit of extra work to make sure you're in sync. If you both change the same file at the same time and try and push, Git gets a little bit upset. It's like, I don't know which one you want to keep. And you have to decide which version you want to keep here. There's a whole process to it. I can show it to you here. Most teams are like, oh, hey, I'm going to work on it today, and then you pick it up after. Or, I'm going to work on it for a few hours, you pick it up after. Works out pretty well. Yep. All right, cool. So let's take a look at our practice midterm. You all had a chance to look at this one, I'm assuming. Very fascinating and fun to do over the weekend, I'm sure. All right, I think you already did number 1, right, or question number 2. Using the modulus operator gives the decimal remainder from integer division of the operands. You can just shout it out.
False.
False? Why is it false?
It doesn't give a decimal remainder.
So to make it true, you would change this to integer. Yep, gives the integer or whole number remainder, right? The integer remainder, right? Awesome. True or false? Square braces are used to create a dictionary.
False.
False?
List.
Yeah, square braces are used to create a list, or you could say curly braces are used to create a dictionary. Either way, you could do this. Again, the goal is you don't put the word not in here. I feel like that's cheating. Like you could say are not used to create a dictionary. Technically, that's true, but like in the spirit of the question. You know, give me something here. If that makes sense. Number 5, blank is the command used to print to the console. Print, yeah. That's like a freebie, right? It has the word print in it. Again, these are not hard. The goal is not to make it hard. A function can return multiple values at a time.
That's true.
So technically true, because what it will do is it will pack them for you into a tuple. So if you wanted to say technically false, it returns a single tuple with multiple values. That's correct. If you just want to call it true because it's technically true, I'll give you the point there too, right? This one's if you want to be pedantic or not and argue about it here, you're never really returning more than one thing. You're only returning one thing, but that one thing can have multiple things. So really, you're just returning multiple things, right? Whichever way you want to look at it, it's fine. Write code that modifies mylist to add 10 to each value. This is like a real short answer one here. There's like 3 lines of code. Right, how would we do this?
You would do mylist update.
I don't think you want to use an update. Usually we loop through it.
It'd be like a for loop for every I or X or whatever you want to use in my list. Add 10.
So let's pull up PyCharm here. Why can't I highlight that? That's fine. My list is 1, 2, 3, 4, 5. Let me add a new scratch real quick. New scratch file, Python. So we had my list equals 1, 2, 3, 4, 5. I'm going to add 10 to each of them. She said 4.
I was just thinking like for number or whatever you want to use in my list. And then my list plus equals 10.
My list plus equals 10.
I don't know, I'm just thinking outside my head.
So this definitely won't work for us, right? My list is still the list here, right? Yeah. Number plus equals 10.
Oh yeah.
You add it back to the list.
How are we going to get it back in the list?
Just append based on the number.
So take my list, append number. Yeah, that, remember, append adds to the end here. So now we'd get 11, 12, 13, 14, 15 added to the end. Remember, this is a read-only version of the loop here. So if you want to be modifying things, we need to use index. Index in range of the length of my list. Right? If you have the index value, now you can change it. Right? Now you can go my list at the index plus equals 10. Because this will change it in place. Right? This can change the value in place. Right? Because you're saying, hey, list at this index, go change your value. When we have the other loop, and we just say for number in my list, number equals, like whatever you want to do here, doesn't change it. Right? We're not changing anything here. Right? We're changing the copy that we have here. We're not changing my list at this point. Okay? So you've got to use the index if you want to change things in your list. You have to reference by index. Right? Again, this was like 2 lines of code here for this, so like real short answer style here. Okay? True or false? If you have a default argument for a function, the argument must be provided when calling the function. Remember, we looked at those default arguments, like, hey, this was define, I don't know, print name and first name. Shouldn't call it print. We'll say print name. First name and last name. And last name will say, hey, if you don't tell me, I'm pretty sure your last name is probably Charnesky, right? We could print first name, last name. So if I have a default argument, it must be provided when calling the function. Is that true or false? False, because it's optional, right? So I could call print name, and I could give it Eric, or I could print name, and I can give it Bob, Smith. Right? Give those a run. Uh-oh. Colon missing. What? Oh, forgot my colon. There we go. Now let's give it a run. Right? So without a last name, it takes the default. With a last name, it uses it. That's these default arguments. That's what they let us do here. Right? So if you have one, you don't have to give it. So that one is false. Did not need to be provided. Right? How about 9? A for loop is guaranteed to run at least one time. Is a for loop always going to run at least once?
Could be at least once.
Could be, but is it always going to be?
No.
When would it not run once?
Maybe if it's in an if statement. It wouldn't run if the if statement isn't correct. Or, like just say you have an if statement and a for loop inside of it.
Well, so the for loop itself. So regardless of where it is the for loop always going to run? Like, if we get to that line of code where the for loop is it always going to run?
Sure. Yeah.
Is this loop going to run? No, because there's nothing in the list. So if you're looping over something that's empty, it's not going to run. It will only run if there's something to loop over. And so it's not guaranteed to run. Right? Your list could be empty. Or you could be asking the user, hey, enter a bunch of things or stop whenever you're done. If they just stop right away, the for loop will never run on us. Right? So it'll only run if there's something in that collection to loop over. Right? Whether or not it's a string or a list or a tuple or a dictionary, like what any of our items here we've looked at, if they're empty, nothing happens. Right? What are 2 reasons to use functions? Yeah. To reduce redundant code, because if you have the same code twice, you should feel bad about yourself.
And make functions that are not built.
What was that?
Make functions that do things that are not built in.
Yeah, so we can make functions to do things that we create.
Yeah.
Yeah. Yeah, we could do that. What's another good reason?
Easier to debug.
Yeah, okay, because we can see just this small piece here that we're looking at for the function when we're debugging. I like that. What's another good reason?
So readability?
Readability, for sure, yeah. It puts a name to what this little chunk of code is doing. That's one of my favorite reasons to use functions, right? My little main section just needs to be like our tic-tac-toe game. It was play a piece, change the player. Play a piece, change the player, while the game's not over, right? Our game then becomes 3 lines of code. That's really easy to see what the game is doing. If I want to know what the functions do, now I can go look at the functions. Yeah?
Could we say break down complex tasks?
Yeah, definitely. To do functional decomposition, right? Make a big task smaller and smaller and smaller, because it's easy to solve the small problems. It's a great reason to use functions, right? I can relatively easily see, did someone win at Connect 4 horizontally? But if you say, hey, tell me if someone won at Connect 4. Well, now I've got to do this one, and I've got to do this one, and I've got to do this one, and I've got to do this one. Like, that's a lot of things to tackle all at once. So why don't we break it down into smaller pieces, right? We're writing the code. We can do it. I mean, there's nothing wrong with doing all of those checks in a single function. But that's a lot of work, right? And then it's going to be even harder to check, did it work the right way? So it lets us test things even easier, too. I can test one small piece at a time. Awesome. When taking a slice of a string, the start and end indexes are optional. Yeah?
I may be wrong, but is it true?
True. Yeah, definitely. If you don't give it the start, it assumes you want the very beginning. And if you don't give it an end, it assumes you want the very end. Yeah, super easy.
For example, sorry for interrupting. For example, you can, if you wanna slice to the end, you can either put -1 after just the column.
Well, so -1 will be one back from the end.
Oh, one back.
Yep. Yeah, so if you want
Yeah,
the
it will does this.
yeah, so if you want the whole thing, right? And really it's kind of silly for strings, like, but that's okay. You can say name is Eric, copy of name equals name sliced. Wait, I should spell copy, right? Okay. This will give you the whole thing. Right. Awesome. Easy. Works out really well. Now, with strings, we know they're immutable anyway. This is more interesting for lists, because with a list, we know they're mutable. So if I give you my list, you can go change values. If I give you a copy of my list, you can't change my values. Right? Did we look at that? So we had, I think we had numbers, right? So this is, we'll print numbers, and then we'll have copy of numbers equals numbers sliced, numbers with an S here. Right. So if we just make a copy of numbers and say, hey, it's the numbers list here, sorry, I don't need that one, then I can print copy of numbers, right, we're going to get, oops, we should give them some values, I forgot, 1, 2, 3. Okay, here's 1, 2, 3. Now if I go change, let's say my copy of numbers here, if I change index 1 to be 42, and we want to print our copies here. They've both been changed. So this is not a copy. When I say, hey, this equals a list, right? Because remember, all a list is, it says, hey, I've got a bunch of values, here's where they start. But now I have the same pointer, I'm pointing to the same location in memory, wherever that thing starts. So if I want an actual copy of it here, if I slice it, I'm going to get a copy, and now I can change mine independently of yours. So when I change mine, it doesn't change yours because I have a copy. So where slicing for lists gets to be much more interesting here. Because now you don't have access to change mine. Right? Sometimes I want people to be able to change my list. Sometimes I don't. Just kind of depends on what we're doing with our code. All right, awesome. The in operator allows you to see if a given value is present in a dictionary. So let's make a little dictionary first here. So here's my, oh goodness, what should we do here? Let's do teams then. Here's a dictionary, and we'll say, how about the team name, colon, and then their city here. So Lions are in Detroit. What's on their team that has a place?
Dallas Cowboys.
So the Cowboys are from Dallas. Okay, what's one more team?
New York Giants.
The Giants are from New York. Okay, cool. So can I use the in operator to see if there's a given value present in the dictionary? Like if, what? Is in teams. Value is present. Which ones of these things are values? So remember, there's two terms we get the dictionaries. We have something and we have values. We have keys. So which ones are the keys?
The team names are the keys and the city's the value.
Okay, so can we say, hey, is Detroit a value in my dictionary? Value is not present. Right. What does the in operator let us do for dictionaries? All right, this should be, remember, it only checks for keys. When you use the in operator on a dictionary, it'll only look for keys here, not values. Right, that's the default for the in operator with the dictionary. Keys only. If you want to see if a value is present, there's ways we can do it. We can say, hey, if Detroit is in teams.values, then we could say print values present. Detroit. I spelled it wrong. Thank you. Look at it. It knows how Detroit is spelled. Go PyCharm. Way to go. Now I can see, hey, the value is present. But by default, if I just look in a dictionary, I'm not going to look for values unless you ask for the values to check. right? That make sense? Cool. When you create a list of lists, a two-dimensional list, you can think of it like a grid with rows and columns. This is true or false? True. Yes, we did with tic-tac-toe. We did it with Connect 4. That's a way for us to visualize it. Now, it's not actually a grid. It's just one long chunk here. It's like, here's the first item, here's the second item, here's the third item. But it's much easier for us to think about row and column, right? Because when we want to think about code, it helps if we can conceptualize it. If it makes sense in our head and we can like have a picture, a model of it in our head, we're much more likely to be able to interact with it successfully. So think of it as rows and columns. It's usually a nice way to think about it here. Now, if you start making a three-dimensional list and you have rows and columns and then you have like layers, you can also sort of do that, but that gets even harder. And then you could go 4 dimensions if you want. And I don't even know what a 4-dimensional cube looks like, honestly. I have, what is it, like a supercube, a hypercube or something? Really smart people can do it. And there's someone does some really nice pictures of hypercubes. And I just don't get it. But that's okay, I don't have to for math. Like, I don't do that kind of math. It's okay. But yeah, right? Just we want to get a visual picture of it for us to make life easier for ourselves.
So we can just say true. We don't have to
Yeah, it's true. If it's true, you just say true. If it's false, then you have to correct the statement. Yep. All right, 14. When looping through keys in a dictionary, you will always go through the keys in the order in which they were added. What do you think? Let's try it. Let's try it and see. So if you're not sure, try it. Try it and see. So let's make a dictionary here. Oh, we've got this one here. So we've got teams here. So teams dot key of, I don't know, apple equals banana. Teams key of cucumber equals, oh, can't even type here, goodness. Donuts. Teams key of eggplant equals fried chicken. I'll just add a bunch here. Teams of grapes equals H. Food with an H. Can't be that hard. Food with an H. Hamburger helper. Hamburger helper. There's a U in there, isn't there? Hamburger. Burger helper. Sure. Let's try it. And then let's say for key in teams, print the key. So the order we put them in is Lions, Cowboys, Giants, Apple, Cucumber, Eggplant, Grapes. Lions, Cowboys, Giants, Apple, Cucumber, Eggplant, Grapes. Okay, it's good so far. Let's add some more. Teams of, so you might think yes at this point, right? Alpha, beta, teams of B equals B. I need a bunch of these here. Okay. C, D, E, F, G, H. All right, let's try that. Okay, still go. We need a couple more. Let's do for range. Let's do 100. Teams index of value equals the value. And then we'll print it. Still doing it. Okay, interesting. We need even more then. Let's do like 1,000. We'll get it here eventually. Come on. Lions, cowboys, grapes, apples. No, still going in order for us. Interesting. Let's do random number, random dot, randint, import random. Oops, sure. Randint 1 and 1,000. Oh, come on. It imported it wrong. Import random. Okay, let's try that. Should get a bunch of random numbers here. Oops, nope. Random number. Still working? Still working. Interesting. Yeah, it should not always do this. I'm really confused. Hang on. I don't know why it's not doing that for us here. Let's do 1 to like 80 here. Let's do the ordinal value of the random number. Just, at some point, it's not going to work for us here. Nope, string of that. There we go. No? All right, well, it's not guaranteed. That's interesting. Might need even more. Because with dictionaries, the order doesn't matter. Right, we can pull that up here. I'll show you. We'll get back to our dictionaries here. We look at dictionaries.
Oh, that is it because like you're just defining. You're putting a detailed value. It's not necessary. It's not like a list.
Yeah, so it's not a sequence type, right? So it doesn't maintain the sequence. Where is it here? Sequence order. Ah, yeah. The order. Oh. No, the order is maintained in the dictionary when printed. Oh. Interesting. Is maintained. That's new. Huh, okay, Python is order maintained dictionary. realpython.com.
Sorting data structures depends on the order of the
Oh
items.
my goodness, stop. Interesting. Okay, so starting in 3.7 and on, it does work. Oh wow, I've been doing this since before 3.7, so my apologies. So it will remember the order. That's fascinating. Wow, that makes things a lot harder to make. Okay, so
Does that mean it's true?
true. Yeah, it looks like that is true. In the order in which they were added. Awesome. I tried to break it and it didn't work. So good job, new Python. That's really interesting. But it's not a sequence type. Interesting. Huh. Okay, neat. I learned something today. It's a good day. That took way longer than I thought, sorry. All right. Having a chain of if, else if statements, an ending else statement is required. Must you have an ending else? No. That's false. Only if you want one. Right, and then our short answer questions here. I'm sorry?
How will we correct it?
So saying an else statement is optional. You could say it's not required, and that's probably one of those times when it's okay to throw a not in, right? I'd be okay with that. Yeah. All right, 3 short answer questions here. Let's do these ones here. All right, so we have ask the user to enter 10 scores, 0 to 100. Ensure the values entered are from 0 to 100, inclusive of both ends. For every valid entry entered, count how many values are greater than 80. Print number of values greater than 80 at the end. All right, so we're going to do something 10 times, right? So I can say for, I don't know, number in range 10. Now I don't actually care what the number is, right? Doesn't really matter here. And then I need a number of values greater than 80. Starts off at 0 until I know otherwise, right? We'll get a number, right? So then I'll ask them to enter a number. So a number is an int of an input. Please enter a number 0 to 100. And then I have to make sure it's valid then. So while number is, now I can do it a couple ways here. So we could say 0 less than or equal to number less than or equal to 100, and all of that with a not. Right? If that's not true, then we're going to ask them again here, right? We can even print invalid number, try again. Valid number, try again. Eventually, if they give me a good number, they get out of the loop here. And well, that's fine. I don't have to spell things correctly here, right? Right. And then if the number's valid, great. Now I can check, hey, if the number is greater than 80, right? Take my number of numbers greater than 80 plus 1. This runs 10 times. And after the loop is done here, I'm going to print you entered as a formatted string. Number of numbers greater than 80, values greater than 80. Right? Should work. Should count them for us. Not too much trouble. Okay? That make sense for that one? So again, just really quick, right? They're not meant to be long here. So let's try it. So if I enter -1, invalid. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll do 100 for the last one here. We entered one value greater than 80. Seems to do what we advertised. Right? Write a function, steps to 1 in 3x plus 1 that accepts an integer value. Oh yeah, this one is a function. Count the number of steps it takes to get to the value 1 by the following rules. If the number is odd, multiply by 3 and add 1. If the number is even, divide by 2. Okay, so we're going to have a function, steps to, find steps to 1 in 3x plus 1, something like that. That takes a number. Okay, so far my steps is 0, right? And while my number does not equal 1, let's do something, right? If my number modulus 2 is odd, then I'm going to multiply by 3. I'll take number times equals 3 plus 1, right? And add 1. If it's not odd, well, it must be even. I'll take number divided by 2, right? And I know I don't need to do integer division because I know it's even. I know I'll get a whole number out here. I'm never going to get a decimal place with this one here, right? And then whether or not that happened, then I'll take my steps plus equals 1. It was one step. Right, when all of that's done then, and I get back to number is equal to 1, I'm going to print it took steps get from number to 1. Right? And we can try it. So I think the first number I gave you, what was like 5, right? Right, that went to 15 plus 1 is 16, and then 8. So that should only be a couple steps here. And we can do this with actually a whole bunch of numbers here. So for number in range, let's go like 100. Let's start it at 1. 1 to 100 here. Let's call this given the number. And let's give that a run. Oops, still got to do all of that. Okay. 1, to get to 1 to 1. What's happening here? Should now be doing 2. I think it's probably upset here with 2. That's unfortunate. Maybe I want that as an integer. Can I do integer division? So I think it probably got upset with that math for 2. Invalid int with literal base 10. Oh, no, that was me. 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay. All right, it's mad about 2. Why does it hate 2? All right, let's put it in debug mode. It should just work with 2. This is obnoxious. 1, 1, 1, 1, 1, 1. All right, here we go. So 1 is fine, so step over. All right, now we're at 2. It's not 2. The number equals 1. Steps is 1. 1 number does not equal 1. You print. Why did it print steps? To get the 2. 0. Yep. 1 to 1 number. Oh, I wanted the original number is why. That's why. So I need that to be the original number. Shoot. 1 sec. Original number equals the number. There we go. Okay, let's try that again. We're almost there. Sorry. Oh, it's time to go, isn't it? Where are we going here? Where's debug? We can play with the rest of this in lab if you want here. We'll do it the first thing in lab. All right, 1 works. 2 works. Now we got 3. 3 is odd. So 3 goes to 12. 12 is even, so it goes to 6. 6 is even, it goes to 3. 3 goes up to 12. No. 3 should have went up to 10. Right? 3 times 3 should have been 9. What happened there? Number 6. 6 is even, so now number is 3. 3. Oh my goodness. My +1 here is screwing it up here. Okay. Number plus equals 1. Let's try that now. Hey, okay, there we go. Now it worked. All right, so one little small error there. Order of operations bit me in the butt. So, all right, we can look at the last one here in lab when we go. So, see you folks in a couple minutes.